Hello again, everybody, and welcome back to Semester 11 Math. Today, we're going to continue our talk on sequences and series. So what we know so far, well, we talked about a few different definitions. Last class, we talked about what a sequence is, and what a series is as well. What we will learn today is we will learn how to derive different formulas for different sequences. So we'll learn about the general term formula, and also the recursive term formula. We'll learn how to derive these, and we will learn how to use them in various different cases. So before we get into it, let's go over a few definitions that we talked about previously. So a sequence is simply an ordered list of numbers. An ordered list of numbers. A series is simply the sum of the terms in a sequence. A term is a number in a sequence. Now, a general term formula is a formula that relates and expresses each term as a function of its position. So it expresses each term as a function of its position. Whereas a recursive term formula is a formula that relates the general term of a sequence to its previous terms. So it relates the general term of a sequence to the previous terms. Right, so with the general term formula, we're able to determine any term within the sequence. With the recursive term formula, we need the terms prior to the one that we're looking for, the one that we're trying to figure out. We need the prior terms to do so. So let's get into it. Arithmetic sequences are sequences that have the same common difference. So they have the same common difference. What does this mean? Well, if we had a sequence such as 3, 6, 9, 12, 18, and so on, what is the common difference? Or what is the difference? Well, here it's 6 minus 3, which is 3. 9 minus 6, 3, 3, and so on. So these are the differences, and since they are the same, we know that it is an arithmetic sequence. Conversely, if we had a sequence such as 2, 4, 8, 16, and so on, well, what are the differences here? 4 and 2, that's 2. But here, 8 minus 4, that gives us 4. So right away, we know that these are not an arithmetic sequence. So they have to have the same common difference. That's important. So let's go ahead and try to derive a general term formula for an arithmetic sequence. So suppose we had a sequence such as -4, 0, 4, and 8. We're going to try to derive a general term formula. And now if we remember our definitions, a general term formula allows us to determine any term within the sequence we want. So if we were looking for, let's say, term 18, we could do so. Term 105, we could also do so using our general term formula. So the general term formula looks like this. This is for only an arithmetic sequence. So what does this formula mean? Well, simply put, t sub n is our term at whatever n we're looking for. So here, if we wanted the 18th term, t sub n would be 18. Likewise, with 105, t sub n would be 105. A is the first term in our sequence. N, again, is the term we're looking for. And D is our common difference. So looking at our sequence above, let's go ahead and try to solve and derive a general term formula. So our first term is -4. Plus n minus 1. And what's our common difference? Well, our common difference, if you could see, is 4. We'll go ahead and distribute the 4 into our brackets. We have 4n minus 4. Collecting like terms, we have t sub n equals 4n minus 8. And that's it. That is our general term formula for the above sequence. So given any arithmetic sequence, we could determine a general term formula as long as we remember what that entails, right? So now, if let's say we were looking for the 18th term, we could sub in 18 for n and solve, and we would get what the 18th term would be. So let's go ahead and do so. So t sub n is equal to 64. So our 18th term would be 64. Great, so that's the general term formula. What about the recursive term formula? Well, let's use the exact same sequence we had. So -4, 0, 4, 8, and so on. The recursive term formula, remember, we need the previous terms to be used in the recursive term formula. So t sub n is equal to t sub n minus 1 plus our common difference. What does this mean? Well, if we were looking again for the 18th term, so we're looking for t sub n to be 18. If we're looking for the 18th term, we need to know n minus 1, so we need to know the 17th term. And then we simply add our common difference. Right, so this is more intuitive, as long as we know our common difference and we know the previous terms. So since we don't know term 17, let's go ahead and look for t sub 5. Okay, so t sub 5 is equal to t sub 4 plus our common difference, which we calculated before to be 4. So if we're looking for the fifth term, we need the fourth term, which we have to be 8. So 8 plus 4, so our fifth term is simply 12. So with sequences, there's also another case called geometric sequences. Now, geometric sequences have the same ratio. Whereas previously we were looking at common differences, now we're looking at the ratio. So if we had a sequence such as 2, 4, 8, 16, and so on, we're looking for the ratio. So we're looking for, let's say here, 4 divided by 2, giving us 2. Next, we have 8 divided by 4, also giving us 2. And finally, 16 divided by 8, also giving us 2. So since the ratios are the same, we know that this is a geometric sequence. If we had something like 4, 5, 2, -1, 10, and so on, well, right away, here we have 5 over 4, and then we have 2 over 5. So right away, we know that the ratios are not the same. Therefore, this is not a geometric sequence. So geometric sequences, the ratios have to be the same. Again, we're going to attempt to derive a general term formula for our geometric sequences. So let's use a sequence such as 2, 8, 32, 128, and so on. Our general term formula is t sub n a times r all raised to the n minus 1. That's our general term formula. So what does this mean? We're looking for a term. We need the first term in the sequence. So a is our first term. R is our ratio. And again, n is the term we're looking for. The term we're looking for. So let's go ahead and derive a general term formula for the sequence written out here. So t sub n is equal to a, which is our first term. Our first term is 2. Multiplied by the ratio. So to get the ratio, we divide second term by the first term, third term by the second, and so on. So to get the ratio, 8 divided by 2, 32 divided by 8, and so on. So our ratio is 4. And our ratio is raised to the n minus 1, n minus 1. So if we were going to attempt to find the 16th term, we simply plug 16 in for n. So t sub n is equal to 2 multiplied by 4 raised to the 16 minus 1. So 4 to the power of 15 is a huge number. 107. So this is 4 to the power of 15. And now we're simply going to multiply by 2. And this would be our 16th term in our sequence. So let's go ahead and try to derive a recursive term formula. Well, a recursive term formula, let's use the same sequence we used previously. A recursive term formula for a geometric sequence is derived from t of n is equal to r multiplied by t sub n minus 1, where r, again, is our ratio, and n is our term. So what is this saying? It's saying it's a ratio multiplied by our term minus 1, so multiplied by our previous term. Because remember, for recursive term formulas, we need the previous term to find out the number we're looking for, the term we're looking for. So let's go ahead and look for the fifth term. Well, t sub n is equal to our ratio, which we calculated to be 4, multiplied by the term of n minus 1, so 5 minus 1. So multiplied by the fourth term. So t sub n is equal to 4, multiply the fourth term, which is 128. So t sub 5 is equal to 512. So that's it for today. All we need to know when we're looking for general term and recursive term formulas is the template formulas that we can go ahead and solve for whatever question we're given.